Hi guys, welcome to my channel. My name is Ria and I took my A-levels last year and got an A star in chemistry and physics. So I'm going to help you out to do the same. So today I will be talking about the planning, analysis and evaluation paper. I know it's a mouthful to say, but let's just dive right in because I don't want to waste any of your time knowing that your exams are coming up soon. This video is going to be divided a little bit. So first I'll talk about physics and then I'll talk about chemistry, and then just if there are any tips that are relevant to both, we'll talk about that in the end. So let's talk about the physics paper. There are two questions in the physics paper. The first one is planning and analysis. So planning and analysis is basically they have something that they want to experiment with, but they don't know how, so they want you to plan an experiment, right? So unlike your practical exam where you had been given the experiment and you just had to perform it, here you're going to be planning and thinking how I can measure stuff, how I can find accurate results. In this paper, there is nothing that they've given you. It's just a blank first 2 pages, right? And you have to write whatever it is that you think is relevant. So this is usually like a 15-mark question, and the marking scheme is split like so. Defining the problem, 3 marks. Methods of data collection, 4 marks. Setup of the apparatus for 1 mark. Method of analysis, 2 marks. Safety consideration, 1 mark. And any additional details, 4 marks. So additional details, what are they? Let's just talk about additional details because this will be spread out through your entire paper. It's basically saying stuff like take 6 readings of the same experiment, 1 mark for your additional detail. So whatever experiment it is, write 6 readings, first step, okay? So let's start with defining the problem. In the definition of the problem, you're going to define your independent variable, your dependent variable, and your constants. So independent variables are the ones that you change, and dependent variables are the ones that get changed because of the change in independent. So on a graph, your x-axis becomes your independent variable and your y-axis is the dependent variable. For example, say I'm dropping a ball from a height and measuring its final velocity right before it touches the ground. So my independent variable is the height, which I can adjust, and my dependent variable is the velocity at which it will hit the ground. So first things first, you have to define it properly. Independent variable is this, dependent variable is that, and your constants are this. That should give you 3 marks. Let's move to methods of data collection. Suppose let's talk about the ball dropping experiment. How will we see what height it is exactly at? So any data that you will be collecting, you have to tell them how you'll collect that. So for this, you get a ruler, make sure it's perpendicular to the ground, take the height and then fix it at that height and then drop. So in this case, how will we measure the height? We'll use a ruler and make sure it's perpendicular to the ground. Usually the experiments are not that basic, so you will have at least 3 quantities that you will be measuring beforehand. So for that, make sure you define everything. Even if we're talking about the ball, right? Are we taking the height below the ball or above the ball? If we're taking above the ball, we'll have to measure the diameter. How will we measure that? We'll put the ball between 2 blocks and then we'll find that. Varna ruler se to diameter अच्छे से नहीं आएगा, right? Now setup of apparatus. It's the blank space given where you will have to draw what your apparatus is. So for my ball dropping experiment, so for that experiment, I'll draw a scale, I'll draw perpendicular ball. How your apparatus should exactly be set up is what you will be drawing, and you'll get a mark for that. Now method of analysis. So in all papers, what you're doing is you're actually testing for some equation. So that equation is either linear, y equals mx plus c, or it's exponential, which is y equals a x raised to n. Or it's logarithmic, where y is equal to ae raised to kx, okay? Whatever data you get, you'll have to talk about plotting a graph for that data. Now obviously we can plot linear graphs itself only. So for y equals mx plus c, the linear form is the same. For the exponential and logarithmic ones, however, you will first have to convert your equation to a linear form. The point of doing this is once you have a linear form equation, you can see whether or not there is a intercept. If there is a y-intercept, your line should not be passing through the origin, right? So this is how you'll check that the graph that they'll make is correct. So you say, since there is a y-intercept, line should not be passing through the origin. Or if there is not an intercept, then you say, since there is no y-intercept, the line should be passing through the origin. That should give you 1 mark. Also, from converting your line to the linear form, you should be able to tell what the gradient is, like what quantity your gradient represents and what quantity your y-intercept represents. Okay, that's also another point. Now let's talk about safety considerations. Basically precautions that you need to take depending on your experiment. I'll link something down below which will go over some common safety precautions, and make sure you read that so you have a general idea of what could be. So that was a general discussion about the first question of your paper. I found a very good website and I'm going to link that below, and it has like general notes, so please go through that. It's a really good website. In the second question, you already have the data that they've collected, and all you have to do is analyze and evaluate that data. Assuming that you've all taken AS level exams before, I'm assuming you know what a best fit line is. There is uncertainty involved in this question, right? So you need to know how uncertainty works, and if you don't know that, search it on YouTube. You should get good videos and just make sure you're aware of how uncertainty works, right? So when you're plotting a graph for this question, you're not going to be plotting points. You'll be plotting points with a bar above and below it, which is nothing but your uncertainty ka range, right? So let me like just show you. So like point and a bar, right? So that is nothing but your uncertainty. So when you're drawing a best fit line, you're going to consider the main center points and draw a best fit line according to that. When you're drawing the worst fit line, what you're going to do is, suppose this is your bottommost point and this is your topmost point. For the worst fit line, what you'll do is connect the bottom of your uncertainty bar to the top. Oh my god, I'm sorry about the but you connect the bottom of your uncertainty bar to the top of your topmost point, right? It's not the worst fit line, it's the worst acceptable line. Okay, so I hope that clears some stuff out. And then again, you have to follow significant figures, find gradient, and the stuff that you've already done in the practical. But if you have any questions, hit me up and I'll help you out. Now to talk about the chemistry planning analysis evaluation paper, there isn't a very common trend like it is for physics. There's no common order of questions, nothing like that. So there's just a few general tips that we can keep in mind. Other than that, you just need to have a good hold over general chemistry, and you should be able to go as they've said if you like just follow what they're saying. First thing is, they will ask, in most cases again, they will ask for an apparatus diagram. And now all of these experiments that you're planning with in the chemistry paper will be based on your practical exams. So it will usually be your calorimetry or titration, so stuff that you've already done. It will not be anything new like physics. So you should have a general hang over the apparatus that is used in the labs. A quick search on the net can give you a list of apparatus that we've used, and just make sure you're comfortable with how they look, how they're used, and stuff like that. You actually have to picture yourself doing the experiment, meaning suppose there is a calorimetry question in which you have to add some amount of substance again and again, the same substance again and again, right? So instead of using a pipette, you could rather use a burette and your job would be much easier. So they even ask questions like, what apparatus would you use for this specific task? And the only way you can be sure of that is if you're actually comfortable with the use of all of them. They also ask for like improvements, and there are some common improvements like in your enthalpy questions, if you add a lid to your cup, you'll lose less heat and stuff like that. And one more thing is safety precautions. Now with the safety precautions, it's fairly easy to deduce what precautions you should be taking. If you're doing like an exothermic reaction, make sure you're wearing rubber gloves, heat resistant gloves. That can be a precaution. Or if like poisonous gases are being produced, you can use a fume cupboard. Yeah, they're just kind of based on like logic, so as long as you know what the poisonous gases are, you should be fine. So those were my major tips. I know this video was more physics focused than chemistry, but that is mostly because chemistry doesn't have any set of questions, that you could expect for sure, whereas physics, it's a fixed format for every paper, and so it's more predictable. So if you have any more questions, please feel free to drop them in the comments below. And also I have a WhatsApp community now for students like you to ask questions directly to me and stuff like that. So if you want to join, please write to me at riyasharkar09@gmail.com and I'll add you to it. Thanks for watching. All the best for your exams.